Hello, in this video we will be looking at how you go about determining the origin time of an earthquake using seismic data and the earthquake P&S wave time travel graph. Okay, so whenever you go through this determining the origin time, this is basically when did the earthquake actually occur. So of course one of the first things that you want to do is you want to determine the actual S-wave arrival time. And then from there you're going to go ahead and determine the P-wave arrival time, and then of course what you're going to do is you're going to go ahead and subtract the P-wave arrival time from the S-wave arrival time. So this gives you a difference of 9 minutes. This is just like determining an epicenter, but we have to actually determine this. Okay, so as you can see by looking at that 9 minutes of difference, this is what I'm looking at from right here all the way up to here. There is your difference of 9 minutes, and so what that's going to do is that's going to give us a distance of 7,200 kilometers. So from station A, the distance to the epicenter is 7,200 kilometers. Now, some key things to actually remember here is when did the actual P wave arrive? Remember, it had to travel 7,200 kilometers before it arrived at 821 00. Okay, and so this is what you're actually looking at. So now we automatically know that the origin time has to be before 821. Okay, because it had to travel that 7,200 kilometers and then it finally arrived there at 821. So how do we go about determining the origin time? Well, the first thing you have to look at and you have to ask, how long does it actually take a P wave to travel 7,200 kilometers? So if you go to 7,200 kilometers along the bottom there, what you'll notice is you'll come up and hit the P line, and then you'll go across and you will see that it takes 10 minutes and 40 seconds for an actual P wave to travel that 7,200 kilometers. So now what we're going to be looking at now is actually determining the origin time. And to do so, you would take the P wave arrival time, and then you're going to subtract that 10 minutes and 40 seconds. Okay, again, that came from the distance. And so from this, what we get, you have to look at here. Now, this is the key component. You notice how this says 821, and then I changed it to 820/60. Let's go ahead and go on through the math here. Okay, the reason I did this is because you're not dealing in tenths. Okay, so you can't subtract like you would just like normal everyday subtraction math, because these are in 60-second intervals. So what I did is to subtract this, I actually borrowed 60 seconds, which is 1 minute. So I made this 820/60. And then what this does is this simplifies it for you. So I just simply turned the 821 into 820/60, which is still 821. Okay, but what it now does is it allows me to do normal everyday math, and that gives me an origin time of 8:10:20. So that's what you're actually going to find. Okay, the hardest part of this is the only time you have to do this, changing it like this, is whenever the time traveled is actually in second increments. That doesn't allow you to subtract this. I mean, you could do it mentally, smart enough, but I always just like to say I'm going to change this and I'm going to borrow 60 seconds. So that's all I did there, is I borrowed 60 seconds. And so this and this are really the same value. Okay, so this explains how you go about determining the origin time of an actual earthquake. Okay, now what's really neat about this, of course, you have 3 seismic stations, and so once you use those 3 seismic stations, you should find that all of them come very close to being at the same exact time. Certain things that would actually explain them not being the same time is, of course, number 1, human error. And number 2, there could be a difference because of the material that the earthquake wave is passing through. Because you have to remember, earthquakes are passing through different rock, and these different rocks are going to transmit seismic waves at different speeds depending on the composition of the rock. So this concludes the video on how to determine origin time, and I hope it was very helpful in helping you understand how to do this.